Have you ever wondered how scientists discover planets in the habitable zones of stars? Our universe is teeming with billions of stars, and many of these stars have planets orbiting them. These planets, known as exoplanets, hold a fascination for us because they may have the potential to support life as we know it. The habitable zone, often referred to as the Goldilocks zone, is that sweet spot around a star where conditions might be just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. Now, detecting these exoplanets is no easy task. Researchers employ four main methods: the Transit Method, Radial Velocity Method, Astrometry, and direct imaging. Each method has its unique strengths and weaknesses and are better suited for different types of stars. Now you might ask, how do these methods work? Let's dive in. Imagine a star's light dimming slightly at regular intervals. What you're picturing is the transit method at work. This is one of the ways scientists detect exoplanets. As these celestial bodies pass in front of their host star, they cause a small, temporary dip in the star's brightness. This dimming allows scientists to not only discover the existence of an exoplanet, but also to determine its size and the specifics of its orbit. However, this method is not without its challenges. It requires precise timing and a great deal of patience, but despite these hurdles, it has proven quite successful. Let's think of a star wobbling in its position. Quite a spectacle, isn't it? This is the core concept behind the radial velocity method. As a planet orbits a star, it doesn't simply circle around. The planet and the star both orbit around their common center of mass. This causes the star to wobble ever so slightly, a movement we can detect from Earth. By observing this wobble, scientists can determine the mass and orbit of the planet causing it. It's a bit like a celestial dance where we interpret the steps from a distance. Despite requiring high-precision measurements, this method is highly effective. Now imagine measuring the precise position of a star over time, or trying to take a picture of an exoplanet. Astrometry and direct imaging are two methods that are as fascinating as they sound. Astrometry is a technique where scientists measure minuscule shifts in a star's position, which are caused by the gravitational pull of an orbiting planet. The star appears to wobble, and this wobble is a telltale sign of a planetary companion. On the other hand, direct imaging is akin to trying to take a photograph of an exoplanet. It's a Herculean task, considering the overwhelming brightness of the host star that outshines the faint light of the planet. But when successful, the rewards are immense as it provides us with direct visual evidence of these distant worlds. These techniques are not without their challenges. Astrometry requires high-precision measurements, while direct imaging demands advanced technology to differentiate between the star's glare and the planet's light. However, as our technology and methods improve, these techniques hold great promise. They are the keys that might unlock the mysteries of countless exoplanets waiting to be discovered. Both methods are challenging but hold great potential for future discoveries. Having explored the different methods of exoplanet detection, let's now turn our attention to an approach that's proving to be a game changer in our quest for habitable worlds. The combined use of the transit and radial velocity methods is considered the best way to find exoplanets in the habitable zone. The transit method, as we learned earlier, helps us determine the size of the exoplanet by observing the dip in the star's brightness as the planet passes in front of it. The radial velocity method, on the other hand, measures the star's wobble to infer the mass of the orbiting exoplanet. When used together, these methods offer a more complete picture of the exoplanets, allowing us to gauge both their size and mass. This dual approach is crucial in identifying potential habitable worlds where conditions might be just right for life as we know it. Each method has its strengths and limitations, but their combined use certainly enhances our chances of making groundbreaking discoveries. So as we continue our cosmic journey, remember that the search for exoplanets is a testament to human innovation and our unyielding desire to explore the unknown. To keep learning about these fascinating topics, don't forget to like, subscribe, and stay tuned for more stellar insights.